In this video, we will talk about double angle formula. This is one of the important sections in Chapter 11. You will have to memorize the formula for Chapter 11 exam. However, formula booklet will be provided for you for the unit exam that consists of Chapter 7 through 11. For double angle formula, it means you're doubling the angle. So instead of sine of theta, you have sine of 2 times the angle. Sine of 2 times the angle is equivalent to 2 sine of theta, cosine of theta. The other one is cosine of 2 theta. Cosine of 2 theta is so special you're given 3 formulas. First one is cosine squared theta minus sine squared theta. Once you know this, you can use trig identity to figure out the other 2 formulas. For example, we know by trig identity sine squared plus cosine squared is equal to 1. If you solve for cosine squared, that's equal to 1 minus sine squared. So then you will be plugging cosine squared for 1 minus sine squared on here. So then you get 1 minus sine squared theta minus sine squared theta. You have then 1 minus 2 sine squared theta. Instead of solving for cosine squared on a trig identity, if you solve for sine squared, you would get 1 minus cosine squared. Plug this in to a sine squared, so you get cosine squared theta minus the whole 1 minus cosine squared theta. Because of the minus, you will have minus 1 and plus cosine squared theta. So you get 2 cosine squared theta minus 1. So the first one is cosine squared theta minus sine squared theta. Second, 1 minus 2 sine squared theta. And then last one is 2 cosine squared theta minus 1. Depending on problems, you will sometimes have to choose which one is the best formula to solve for an equation. So here I wrote down the formulas that was provided on the first slide. Given that sine of an angle is equal to 3/5 and cosine of angle is negative 4/5, find sine of 2 alpha. Well, sine of 2 alpha is equal to 2 sine of alpha cosine of alpha. Sine of alpha is given, cosine of alpha is given, so simply plug it in and then simplify. You should get negative 24 over 25. To find cosine of 2 theta, in this case you can choose any of the 3 equations. If you choose the first one, you would square the cosine value, so negative 4 over 5 squared, minus square the sine value, so 3 over 5 squared. You get 16 over 25 minus 9 over 25. The answer comes out to be 7 over 25. If you chose the second one, you would get 1 minus 2 times sine squared theta. Sine, again, is given as a 3 over 5, so 3 over 5 squared is 9 over 25. Multiply that by 2, so you get 18 over 25. So putting 25 over 25 as a 1, you get 7 out of 25 again. So any of the 3 formulas will work in this case. Sine of an angle is equal to 5 over 13, where angle is between pi over 2 and pi, so that is on the second quadrant. Find the exact values of sine of 2 alpha. If sine of an alpha is equal to 5 over 13, sine is opposite over hypotenuse, so on a second quadrant, drop it down perpendicular. Opposite is 5, hypotenuse is 13. To find the value of x, keep in mind this is on the left side of the y-axis, so this value of x must be negative. So we can use the value of x by using a Pythagorean theorem. X squared plus 5 squared is equal to 13 squared. So x squared is equal to 169 minus 25. Simplifying, you get 144. So x squared is equal to 144. To solve for x, you want to take the square root on both sides. When you're taking a square root, remember, you get a positive and negative value. In this case, x has to be negative. So x is negative 12. To find the sine of 2 alpha, sine of 2 alpha is 2 sine of alpha times cosine of alpha. So you get 2 times cosine of alpha, which is given as a 5 over 13, and cosine of alpha, cosine of an alpha is equal to adjacent over hypotenuse, and adjacent is negative 12 over 13. So plug negative 12 over 13. Simplifying, you get 2 times 5 is 10, 10 times 12, that's 120, all over 13 squared, 169. So answer should be negative 120 over 169. If alpha is acute means it's less than 90 degrees. So that has to be on the first quadrant. Cosine of 2 alpha is 3 over 4. Find the exact values of cosine of alpha and sine of alpha. You know cosine of 2 alpha comes in 3 equations, and you want to think about which one is the best one I can use to solve this question. If you use the first one, cosine squared minus sine squared is equal to 3 over 4. In this case, you're given 2 unknown variables and 1 equation. Therefore, you can't solve this question using the first formula. If you use the second formula, you have 1 minus 2 sine squared is equal to 3 over 4. So this one is a possibility. If you use the third one, you get 2 cosine squared minus 1 is equal to 3 out of 4. So this is another possibility. So you can use any of these 2 formulas to solve for cosine of alpha and sine of alpha. If we used the second one, we would have 3 out of 4 is equal to 1 minus 2 sine squared theta. Here I just changed the order on left and right. In order to solve for sine of an alpha, you want to subtract 1 on both sides. So you get negative 1 over 4 is equal to negative 2 sine squared theta. Dividing it by negative 2 on both sides, which is same thing as multiplying by half, negatives become positive and you're left with 1 over 8. Square root both sides, you get plus minus, but in this case you're only considering less than 90 degrees, so the angle has to be positive. So it'll be positive square root of 1 over 8. Once you figure out that sine is equal to square root of 1 over 8, you can use trig identity to solve for cosine of theta. Cosine of squared plus sine squared is equal to 1, and you know sine squared is equal to 1 out of 8. So plug that in. So cosine squared plus 1 over 8 is equal to 1. Subtracting 1/8 on both sides, cosine squared is equal to 7 over 8. Taking the square root on both sides, again, because it's on the first quadrant, cosine, the x value has to be positive. So cosine is equal to square root of 7 over 8. Here I have provided the double angle formulas, so we will be using this to simplify the expressions. Use an appropriate double angle formula to simplify. We're given 3 sine of theta, cosine of theta. This one looks similar to the first formula. So we're going to think about how can we make 2 into 3 by multiplying 3 over 2. So we get 3 over 2 sine of 2 theta. Checking the answer, you can also do 3 over 2 sine of 2 theta, which we know sine of 2 theta is equivalent to 2 sine of theta and cosine of theta. So 2's will cancel out. You're left with 3 sine of theta, cosine of theta, which is the problem given to us. Second one, we have 4 cosine squared 2b minus 2. So here we have a common factor of 2 in these two terms. So factor out the 2, and then we're left with cosine squared 2b minus 1. Notice in here, cosine of 2b is an angle, so you cannot factor out the number inside the angle. We have cosine squared 2b minus 1. That looks most similar to this one. If cosine of 2 times the angle, then 2 cosine squared angle, this angle gets doubled. So if you have a 2 theta, this should be 4 theta. So we have 2 cosine of 4b. If we have another question, 2 cosine of 3x, sine of 3x. Although it's written as a 3x, these are your angles. Angle A. 2 cosine of A, sine of A. That looks most similar to the first formula given to us again. Here, if we're given an angle theta on the right side, this gets doubled, so we have 2 theta. So if you're given 3 theta, it should be 6 theta. So the answer should be sine of 6x. Lastly, we have 1 minus 2 sine squared 5 alpha. This one is most similar to the second formula on cosine 2 theta. Again, we have 1 minus 2 sine squared of 5 theta. So this angle gets doubled. So it should be cosine of 10 alpha.